All right, now we're looking at saturated fatty acids versus unsaturated fatty acids. These actually hear a lot about. They're in health. They're in a lot of the foods that we eat, and we talk about the unsaturated fatty acids being healthier generally than our saturated fatty acids. So first of all, what they are, saturation is a Greek word. It means filled up with, full. In this case, a saturated fatty acid. So here we have a saturated fatty acid. Again, there's that carboxyl group on the top, on the head, and then the long chain of hydrocarbons. This is saturated because it is full of hydrogens. It has the maximum number of hydrogens. Every carbon in the tail has two hydrogens, and the very last carbon here even has three hydrogens. Unsaturated fatty acids, so not full, not saturated fatty acids, they do not have the maximum number of hydrogen. And why is that the case? Well, they tend to have at least one double bond between the carbons. So you can see here, here's a double bond between two of the carbons in the middle of the chain. And in order to make that bond, these two carbons involved had to give up a hydrogen atom. So they're not full. We don't have the maximum number of hydrogens. You notice these two carbons sharing the double bond, they each only have one hydrogen attached to them and not both. So this becomes really important, again, especially in the foods that we eat and in our own health, because we have kind of a kink. You saw it on that last slide. There's a bend in a chain of hydrocarbons that has a double bond that we don't tend to have in a saturated fatty acid, which are generally pretty flat. We have to get into a bit more chemistry than what we're going to discuss why that's the case. But we'll take a look at our triglycerides. So here's our three parts we are hopefully pretty well aware of. We have the glycerol head up top. There's those three carbons. We have the carboxyl group, which is the link between the hydrocarbon tail. We've got three of them. And the glycerol. And then here we have our three fatty acid tails, the hydrocarbon tails coming off. So this is a triglyceride. And think of that word tri. There's three tails stuck to a glycerol. And the last one, the last fatty acid chain, has that double bond and is therefore unsaturated. Does not have the maximum number of hydrogens on it. And again, there's that kink. It kind of kicks out sideways because of that double bond. Well, because of that kink, when you line them up, when you package these fatty acids, the unsaturated versions don't pack very tightly. So you can kind of see that here. We've got these kinks in the tails. They don't lay flat. And so you can't put a whole bunch of unsaturated fatty acid tails together. They just don't package very well because of that double bond and that bend in the chain. We look over here on the left, and we've got all saturated fatty acids, and they lay very flat. You can package them very nicely. They fit together very well, and that makes for a denser fatty acid, a denser fat. These tend to be solid at room temperature. We're looking at butter here. Meats tend to have a lot of saturated fatty acids, so again, solid at room temperature. They lay fat, they package, they're denser than our unsaturated fatty acids because of those kinks. So great examples of unsaturated fatty acids, oil. Oil's a liquid. It's not as dense as, again, our counter example here is butter. Oil is much less dense, and we tend to think of it as being healthier for us because they don't package as tightly because of those double bonds. Again, some foods that are saturated fatty acids, we've got our bacons, we've got our cheeses, we've got our meats, we've got a lot of solids versus our unsaturated fatty acids, which again tend to be healthier and less dense.